Hi everyone. Today we're going to expand our knowledge of logarithms by learning about some of the properties of logarithms. So if we have two logs added together, or two logs subtracted, or a log with an exponent in it, how do we rewrite it to make it look simpler? So the first thing I want us to look at is if I do log of 5 plus log of 6, do that on my calculator, I'm going to get 1.477. Now there's a log that is the same value as 1.477. Now, hopefully, you think to yourself, okay, let me try different numbers. Maybe I try log 11. Log 11 doesn't work. Maybe I try log of 30. And log of 30 in this case does work. And log of 8 plus log of 11 winds up being log of 88. The decimals are equal. So test them out, check to see that it's true. And then the product property of logs states if they have the same base, we can multiply their arguments. So we can do 7 times 7 or 8 times 11. And then subtraction is called the quotient property. If I see subtraction of two logs with the same base, I can divide the arguments, divide what's inside the parentheses. So 14 divided by 2. So log A plus log C is log A times C as long as the bases are the same. And log A minus log C is log A divided by C as long as the bases are the same. There's also a third property. So we're going to look at log of 7 plus log of 7 again. So log of 7 plus log of 7, we just saw we can multiply the 7, so we get 7 squared. So log of 7 plus log of 7 equals log of 7 squared. Since we're adding two of the same thing, we get 2x, so x plus x is 2x. So log of 7 plus log of 7 is 2 log of 7. We have two of them, which means that these two expressions have to be equal. So log of 7 squared equals 2 log of 7. So anytime you see an exponent in a log, you can pull it out front. So log of a to the x equals x times log of a. And this is going to be really helpful when we get to solving because we're going to not want exponents. We're going to want the log of just a number. And we're going to want the exponent out front. And this is called the power property. So those top three properties, the product, the quotient, and the power properties are ones we've just talked about. We're going to practice those today. And for the top two, the bases have to be the same. So don't go combining logs with different bases, can't do that. Now, two other cool properties is the identity property. So log base b of b, so when the base and the argument are the same, the answer is always 1, because b to the first power is b. And then the log of 1 is always 0. I don't care what the base is, because what this problem is saying is b to the 0 power equals 1. So when we have the log of 1, or the natural log of 1, the answer is always 0. And log base b of b, the answer is always 1, as long as they're either matching or we have the argument is 1. So what we can do with this is we can take one log and split it up into a bunch, or we take a whole bunch of logs and combine it down, condense it. So this one, I have one log, I want to make multiple logarithmic expressions. Okay, I'm going to use the product property. So all this inside is multiplication, so I'm going to make it a giant addition problem, all with log base 4. So I'm going to break apart the 5, the x cubed, and the y into 3 separate logs, all with base 4. So log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Now, the first and the third expressions can't do anything with them, but this one has an exponent in it, and we just learned that we can move the exponent out to the front. So instead of having the 3 as the exponent, we can move it out front and get 3 log base 4 of x. Notice that the base didn't change. The bases are still 4 for all of them. We just split it into 3 different logs, and we move the exponent. And once again, this is going to be helpful when we get to solving, and we need to move the x, move the variable, get it outside the log. Now we can also evaluate logarithms. So let's say I give you the natural log of 34, and the two pieces of information I give you are the natural log of 17 and the natural log of 2, and I tell you what they're equal to. You can do this without using a calculator. So let's look at natural log of 34 and say, how does it relate to 17 and 2? So 34 is 17 times 2. So now as a multiplication problem inside of my argument, I can break them down to the natural log of 17 plus the natural log of 2. And since we know both of those as decimals, we can just add the decimal approximations and get a final answer. So whenever they give you natural logs, if we know other natural logs, we can expand, break it down into simpler natural logs or logarithms, and evaluate based on information we already know. Now we're going to take and use these properties when we eventually move on to solving with logarithms and natural logs.